Hello, today we are going to have our second day of graphing rational functions. Today we're going to look at rational functions when they are not factored initially, and then we will also look and see what happens when we have removable discontinuities. All right, so if we have f of x equals x squared minus x over x squared plus 2x minus 3, the first thing we need to do is factor it. So if I factor this numerator, this is going to be x plus 3, x minus 3. If I factor the denominator, we have to think about two numbers that multiply to negative 3 and add up to 2. That's going to be x plus 3, x minus 1, because 3 times negative 1 is negative 3, and if I add them, I get to 2. All right, so f of x equals, here's our new equation. Now let's see if there's a removable discontinuity. Is there anything in the denominator that divides evenly into the numerator? And that question should be answered with yes, x plus 3. And so this is going to give us the point of our removable discontinuity. So negative 3 is not a 0. It is not a vertical asymptote. It is a removable discontinuity. So, so the coordinates of the removable discontinuity, the x value will be negative 3, because that would be the value where it's discontinuous, or 0 if we didn't have that other corresponding part. Now this, if this isn't necessarily equal, but if we canceled those out, it would be x minus 3 over x minus 1. And I have a little arrow here rather than an equal sign because they're not quite equal. But the graph is similar to this, except for the point where of the removable discontinuity. So if I plug in negative 3 into this function, that would be negative 3 minus 3, which would be negative 6, negative 3 minus 1, which is negative 4. So that removable discontinuity would be at negative 3. Well, this would be 1.5. There you go. Now the zeros of this function and all of the rest, we just looked at the remaining part of our function. So our 0 will just be 3, 0. Our y-intercept, if I plug in 0 for x, 0 minus 3 is negative 3 over 0 minus 1, which is negative 1. So negative 3 over negative 1 would be 0, 3. The vertical asymptote will just be 1. That'll be at x equals 1. And the end behavior. This is actually pretty good for looking at end behavior because x squared over x squared, that's 1 over 1. So y is equal to 1 will be our end behavior. Now we'll look at the sign chart and then sketch our graph. Our sign chart looks like this, where our values are going to be the zeros, which is at 3. I'll put a little z down here to denote that that's a 0. And our vertical asymptote, which we have at 1. Now, if we can just use this part again to determine whether it's positive or negative. If I pick a number greater than 3, say 4, 4 minus 3 is positive, 4 minus 1 is positive, so positive over positive is positive. If I pick a 2, which is in between these two values, 2 minus 3 is negative, 2 minus 1 is positive, a negative over a positive would be negative. However, if I pick 0, we've already done that. If I put in 0 for x, we get a positive 3 out for y. So now we have our sign chart positive, negative, positive. So now we're going to graph this. And we'll put all of these points on here. So first I'll scale this out. And here my scale is just 1. Try to make them as even as you can. Oh, that wasn't as even as I could. Let's try that again. That's a little bit better. All right, so if we put these points on, -3, 1.5, if I go at 3, 1.5, that's my removable discontinuity, which is just an open circle. My 0 is at 3, 0. That's a solid circle. 0, 3 is my y-intercept. My vertical asymptote is at x equals 1. So at x equals 1, I'll draw my vertical asymptote. My horizontal asymptote is at y equals 1. And now I have all of the information. Now I just have to draw it. Now it says that it's going to end up over here and end up over here. That's what end behavior is. Our vertical asymptote, what happens on the far left and far right. Our sign chart tells us whether we go down or whether we go up. Since this is positive, this has to be positive the whole time, and it has to pass through that point, until it hits that axis. Now, just to the right of this, we can either start at the top or it can start at the bottom. Since it's negative, it has to start at the bottom. And it keeps going until it gets to 3. And at 3, it says it's going to be positive, but we also know it's going to tend towards this line. So we can draw our rational function to look like that. All right. I want you to try this one and see how well you do. So hopefully you've paused the video and you're back. If I factor this, f of x will equal 4x can come to the outside, leaving x plus 2 left over. Now if I factor this, the two things that multiply to 10 and add up to 7 are x plus 2, x plus 5. So since there's an x plus 2 in both of these, the coordinates of the removable discontinuity would be -2. To solve for the y, I would simplify this, and it would be 4x over x plus 5. So if I plug in a -2, that would be -8 over 3, which we can just write that as our answer. It would be -2 2/3. Our 0, what would make this numerator 0? Well, only 0. So 0, 0 is our 0. Our y-intercept, if I plug in 0, that would be 0 over 5, which is still 0, 0, which makes sense. If the 0 is at 0, 0, the y-intercept has to be there also. The vertical asymptote, what makes this denominator 0? And that would be x equals -5. For end behavior, we look at our coefficients on our largest degree, so that would be 4 and 1. So that would tend towards y equals 4. Now we look at our sign chart. What we put on our sign chart is our 0 and our vertical asymptote. So -5 and 0. And now we say anything to the right of 0, say 1. 1 over 1 and 1, those are both positive, so that will be positive. Between -5 and 0, if I put in -2, that would be -8 over a positive, so that would be a negative number. And now if it's less than -5, say -6, we'd have a negative over a negative, which would make it positive. All right, so now we draw out our graph, make a quick sketch. I should scale it first. All right. Now, to fill in all of the information that we've collected so far, we have a point at our removal discontinuity, I should say, at -2, -8/3. So -2, -2 and 2/3 would be down here. 0 at 0. Y-intercept is also there. A vertical asymptote at x equals -5. So that would be over there. Could have scaled this a little bit better. And then an end behavior at y equals 4. Looks like that. All right, so now we just have to sketch it. Our to the left, it's going to go towards 4. But as I go to the right, it can either go down or up. But since it says positive, it has to go up. Now to the left or to the right side of that, it can either start at the top or the bottom. But it says to the right of -5, it's going to be negative. So it's going to start down here, pass through this point, pass through this point, and then go off towards our axis. Notice it's positive from 0 to the right. And now we're done with this problem. And what it'll actually probably look like is probably curve like this and then come down like this. Yeah. All right, so there is our function. Do this one, pause it, and see how well you can do on your own. All right, now we're going to walk through this. So if we factor, we'll get 4 minus x over x minus 2 times x minus 1, both in the denominator. There are no removable discontinuities. The 0 would be at 4, 0. Y-intercept would be at 0, -2. Vertical asymptotes would be x equals 2, x equals -1. And behavior is at 0, and this is our sign chart. Now when we do this, now let's use the sign chart to graph it. So I did everything except for the graphing, just because that's probably the most confusing part. So if I start on the left-hand side, it says that it has to be positive from here until it gets to -1. So that means it has to go up. Now between -1 and 2, in this interval, it has to be negative the whole time. So it has to start low, come up, and then end low. And then to the to the right of 2 is going to be positive. Okay, I thought I screwed up for a second. But it's positive, so it's going to start at the top, come down, hit the that point. It's going to be negative, but it's got to tend back towards this line. So it's got to curve around and move out there. All right, hopefully you got the same graph. And try this one and see how well you do. All right, hopefully you are done with this problem. Here's our function. If I factor it, I'll get these values. There are no removable discontinuities. It has 2 zeros at -5 and 1, a y-intercept at -5/16, and there's only one vertical asymptote, and the end behavior is going to be y equals 1, and this is what I got for my sign chart. So as I graph this, it's going to start off to the right and be positive, come down and hit this 0, and then it has to be positive from -5 to -4, so it can't continue down. It has to turn around and start going up. Now just to the right of -4, it's got to be negative, so it's got to start at the bottom. And as it goes to the right, it has to hit the y-intercept, go through our 0, and then after our 0, it's going to be positive as it goes out towards our end behavior. So this is what the graphic's going to look like. It's going to come down, hit, turn around, and then go off to the right. All right, that is it. Now there is a worksheet that you can do, and hopefully you can do it.